Today, I'm speaking with Sébastien Moro, a science writer and a video blogger covering animal cognition. He focuses primarily on the animals that most of us find not so cute, and that's basically what we're going to focus on today.
The ingenious innovations of Atlantic cod.
If there was one study that blew my mind, it's the one I'm going to explain now. And we've talked about mirror test, in the wrasses. But this one it's uncanny, really. So it's a paper on Atlantic cod. And at first, this study was about self-feeder for aquaculture. So in aquaculture, it happens that the fish have self-feeders, so some kind of devices they activate themselves to get food. So the idea was just that. At first, they were, if I remember correctly, they were trying to find food preferences in this fish. So first, they need to recognize each fish. So what they did, they put a tag in their back with a bead on it. So a colored bead. So you have the fish with the blue bead, the one with the red bead. Okay. And then inside the tank, you have a self-feeder. So how does it work? Let's imagine again a square tank seen from top. On the top left, you have the device. The device is a pull string with a kind of another bead at the bottom. And the idea is the fish comes, take the bead in its mouth, pull. Then there is a light that switches on top of the device. And the self-feeder is releasing food on the top right. Okay? Which is kind of problematic because it means that the fish that pulls is not the first one where the food is.
Right, because it's on the other side of the tank.
Exactly. It has to open the mouth. Okay. So they were trying that and it was working pretty good. And then, so it happened with 3 fish, but I will concentrate on one. There is one fish who got trapped in the bead of the pull string with his own bead, the one in his back. So there is a video of it. So you can see the animal getting locked in it. So it starts to get scared, try to move, but can't. But the device is working. The fish is pulling, so the light goes on, the food is given, and the other fish are going to eat. And finally, this fish managed to unlock himself and move. Okay. And then the weird thing is scientists started to see this fish trying on purpose to get stuck in the bead again. And they were like, what the fuck is this animal doing? And the fish started to be really good at it. And at the end of the experiments, the numbers are something like the animal used his or her mouth 40 times and the bead 522 times. Why? Because when you pull with a bead in your back, you can have the head where the food is coming.
I see.
And so what they observed is that each of the 3 fish who did that, fishes, learned a different technique and they improved it. And like when you watch the 10 first trials, they're just trying in a kind of an easy way to get locked in it and then free themselves to go to the food. But the 10 last trials, it's amazing. Like really, the animal is going down, grabbing the pull string with their own bead, pulling while turning, which allows them to free themselves. And when the device is activated, they are already free and the head under the food, which means they are using an artificial limb that is in their back that they cannot see to overcome a difficulty. It's something that was not expected by the scientists. At no point they thought they would see that. They've been publishing a paper just on this, aside the one they were preparing, because it was insane. And it's Dr. Octopus.
Yeah.
Like they have one arm. It's what?
Yeah. So they basically just like mastered they made up a new way to make sure that they're quicker to get to the food as it comes out. And then they experimented, improved upon it, And now it's
Yes.
like the Olympic Games of using their extra tool appendage
Absolutely.
bead on their back to be quick to the food. That's absolutely incredible. It's tool use, but it's so flexible, and it's also just nothing. I mean, I can't think of anything in the environment that would that would make you think that they'd have any kind of related skills or not learned, but inherited kind of behavioral techniques.
Yeah, this is really, really something. Honestly, the first time I read that, I was like, okay, I'm going to read it again. I misunderstood. And I didn't. And nobody ever talked about this paper. Every time you can see stuff about how fish are smart, this one is never in it. And it's an amazing paper.
The mirror test triumph of cleaner wrasses.
The idea is you put a subject in front of a mirror, and then if the individual can recognize himself or herself, he will go through different stages. So the first stage is you don't know it's you, so you consider that it's someone else. So you should start to see some social behavior. And after a little while, the subject will start to understand that there's something going wrong there. Something's not right. So you should start to see weird behaviors that aren't used in the social context, like moving your hand to see if the other one is doing the same thing. Then the next stage is the subject understood that, okay, it's his reflection. Right. So you should start to see self-checking behavior. And so the last part to officially validate the success to the mark test, you put asleep the subject and then draw a mark where they cannot see. So usually it will be on the forehead, or the side of the head, on the chest, this kind of stuff. And then when the subject wakes up and look in the mirror, either it doesn't care, either it's starting to try to remove the mark on him. So it means that the subject understands that it's his reflection and he can orient the movement toward himself or herself. And then there is also the option that the subject doesn't react at all. So they've released last year, very recently, the most amazing test ever that hasn't been done on any other animal. They've made a photographic version of the mirror test. So nobody could say it's scratching. It can't because the fish has no mark. So first they made them pass the mirror test, all the stages and everything. But this was the training. So now this test is just a training for them.
Right.
And then the test was you take a picture of this very fish and you draw a mark on him or her. Or you take a picture of another cleaner wrasse with a mark. The animal tried to rub himself or herself only when it's a picture of him or her. It's not all. I have worse.
Wait. Okay, I just want to make sure I understand that. Okay, so you take a picture of the cleaner wrasse and you draw a mark on them. And if they try to rub the mark off, that's already pointing at something like they didn't get any injection. They're not feeling anything. There's just like nothing physically there that would make them, for physical reasons, want to rub it off, except for the fact that they think that they see it in a reflection of them. But then it's not just that. It's that they only do it for the pictures that are recognizably of them, which is incredible. And I guess, so that means when they were doing the original training for the mirror test, they saw themselves in the mirror and they learned what they looked like. Yes. And they learned to differentiate that from what other cleaner wrasse looked like.
Yes.
That is an amazing result. Sorry, you were about to say, I think it gets more impressive.
Yes, you're understanding right. There is a second part to this test.
Okay.
They wanted to know if the fish are recognizing themselves by the face, as we do in humans, or by the body, or a combination of both.
Okay.
And we know, for example, that humans are really using the face primarily. So what they did is they took Photoshop. And so they took two pictures of fish, one of the focal animal and one of another one. And they've cut the heads on the pictures and put the head of the fish, of the focal fish, on the body of another one, and the head of the other one on their body. And they've tried it again. And it appears that they're attacking their body with the head of someone else, but they're not attacking a picture of their face on someone else's body. So it means that they can recognize themselves in pictures from the face exactly as humans do.
Wow.
This is the best mirror test ever. Actually, the animal that is succeeding it the most convincingly, except for humans, is the cleaner wrasse.
The astounding accuracy of archerfish.
We'll have to talk about archerfish, called Toxotes, scientific name. And they are fish who are hunting fish. They're eating mostly insects. And when they're young, they're eating prey in the water, as every fish. But as they grow, they start to spit water spray out of the water. They spit, literally, to hit insects which are on the leaves of the plants above the water. But this is not something that is instinctive. They have to learn it. At first they're bad, and then they're better. More impressive, they slowly learn to hit moving prey. And they can hit moving prey, they can learn that just by watching other fish doing it without even trying it themselves. And once you release them, they're able to do it. Now, because this seems impressive, but it's not as much as it is really. Because we have to remember that these fish, they're not territorial. They move all the time, which means that they don't know the place. So they really use their sight to hunt. Then when you are in the water, when you're comparing to the air, there is a refraction index that changes. So where they see the insect is not where the insect is. Exactly when you put your arm in the water, it looks like your arm is broken, but it's not. It's refraction index. And they can just correct for the refraction index, knowing that this refraction index will change according to the pressure or to many things. And they can adapt it to the height of the prey, the speed of the prey, if there is wind or no wind, which they can't feel because they're in the water. And they can shoot a prey and calculate where the prey will fall to be exactly at the landing spot of the prey to be the first one to eat.
Incredible.
And their visual cognition is so good that they can even recognize human faces, which is totally insane because in their life, they shouldn't be recognizing.
Never encounter human faces, right?
Exactly. And they can. And even more impressive, they've shown that they can recognize faces of human with rotations. So they learn to recognize the face of someone, and they can recognize someone. And when you put this face next to one face and 44 different faces, they can still recognize this one. But if you learn one face and then I show you a profile of this person, it's much harder to recognize this person. Monkeys, primates have a hard time doing it. The archerfish can do it. It's insane. Their vision and their ability to understand visual stuff is crazy, like really, really crazy. So here, we cannot say that water is not tool use. They're using water as a tool. And they even watched in detail how the jet, how it's made. And they found out that they change the shape of their mouth when they're spitting. So the end of the spit is bigger or smaller. The track behind is longer or not, just to be precise on the distance. So they're really very precise on how the spits. It's ballistic.
The magnificent memory of gobies.
There is a very interesting and funny story. And it's one of the first paper we have on fish. It was in the 50s and 70s, so it's really old. And one guy noticed that gobies, these fish, they're first living at high tide. And they're checking the topography of the floor of the sea, okay? Then the tide is going away and they're choosing a pool to be their home pool. And when the tide is away, they're living in a small pool. And the guy working on that, Lester Aronson, discovered that these fish were just sometimes jumping from one pool to the other. But the problem is, when you're inside the pool, you don't see the other pool.
Right.
But the fish were insanely accurate. So the question was, can they somehow fly? And so they jump the spot where the next pool is and they're flying to there? Or do they remember? And so what he did is he first checked what they were doing. And it seemed they were scanning at high tide, memorizing the full area, and then jumping from memory. And he proved it. How did he do? First, he took the fish in the home pool and brought them to somewhere else, different pools that these fish never saw before. The fish were not jumping anymore. And when they were jumping, they were falling on the stones around, on the rocks. They were missing pools all the time. So that was first interesting things. And then a few days or even weeks later, he brought them back and they still remembered. So they had a topographical map in the mind that they saw from top at first in the high tide, and then from inside in subjective view, and they could still jump precisely. And there have been many tests on this fish, even a recent one, that showed that they can remember the area for at least a month, and probably more.
That's insane. Okay, so it's something like there are like hills and low points in the sand or whatever the bottom of this area is, such that when the tide goes down, some of the like low points are still have water in them, and those are the pools. And while the water is still high, not only are they able to work out that the deep bits are going to be the pools, they also create a map. And they create a map with enough accuracy to, while in one pool, know that if they go like 36 degrees to the left, they will be in another pool. That is...
And they can go back to the sea.
Jumping pool to pool. I mean, I feel like I'm like, but do they remember things for more than 3 seconds? And you're like, they actually remember better topography than humans do. like there's no chance I would do that. That's amazing.
The tactical teamwork of the grouper and moray eel.
Now I'm going to something even more incredible, which has been studied in depth, the grouper and moray eel interspecific hunting. So, what is a grouper? A grouper is a carnivorous fish which is massive. It can go up to 2 meters long. It's really massive fish. It's a Formula One fish. It swims very fast. It's very big. It's very powerful. It has a massive bite force. Okay. And it's diurnal hunter. So it hunts only during daytime. Now we have the moray eel. Moray eel are very snaky-shaped bodies. They are nocturnal hunters. They don't hunt during daylight. And they are more made to go inside crevices, inside holes, and this kind of thing. So 2 very different hunters. The groupers, when they are hunting a prey, it often happens that the prey is hiding inside a coral reef. And at this point, the grouper can't get inside. Well, the grouper developed a communication with the moray eel with a kind of head shaking. We have lots of videos of it. It goes to find one moray eel and shakes its head above the moray eel to ask the moray eel to come and hunt with it. Sometimes the moray eel will accept. Sometimes it won't because it's sleeping. So let's say it's coming. If the moray eel finds another hole, it might go inside and sleep. So the grouper will come back and go like, oh, we're going to hunt. And then what the grouper is doing, the grouper is coming exactly where the prey entered inside the reef. And the grouper will point at the hole. This is one of the only referential gesture we know in animals, because it means that the fish is not communicating just a feeling, an emotion, or something like that. It's pointing at something external from him and saying to the moray eel, you had to get here. And the moray eel understands it and get inside. You can find videos everywhere on YouTube about that. And this is quite amazing because almost everything is directed by the grouper. And then the moray eel gets inside and the grouper is waiting outside of the reef. And there is no sharing of the prey. It's either the moray eel gets the prey or the prey escapes from the reef and she has a massive Formula 1 killer waiting for it. And so either the grouper wins, either the moray eel wins, and then they continue hunting like that, so each one has their meal.
Huh. So they're not even sharing it. They're just like, one of us is going to win, but it's worth it to both of us to do this because
absolutely.
Because then one of us gets something.
And they found out that groupers can hunt with pretty much any animal that will accept to hunt with it. Like we have videos of some species of grouper hunting with octopi. We are now talking about a vertebrate hunting with an invertebrate together and communicating. This is something we don't have on land. That easy. And we have... Well, one interesting thing is when they don't know very well the environment and don't really find someone to help them, they will just point until someone finds and help them. And sometimes they can point. They have been observed pointing for up to 30 minutes.
My goodness.
So it's really impressive. And sometimes it's fish, there are fish with very strong jaws and they can bite inside the coral reef. So sometimes they're hunting with these fish. It depends a lot.
The remarkable relationships of wild guppies.
So social learning sounds at least present for some species. Do fish have kind of recognizable relationships between each other? Do they seem to form bonds? What else are their social lives like?
Oh, I love this question. So, do we know if they form bonds? There have been many species tested for that, especially guppies. We've discovered social networks in guppies. Especially there is one paper on white guppies where they really built a social network. They took every animal from a pond. Well, actually, it's 2 ponds that are linked by some water flow. And they found out there were 3 communities of fish always interacting together. And between those communities, there were animals doing a link between the communities. They were always switching from one to the other. And you have central animals with lots of relation with a lot of other animals. You have more peripheral animals. You have a lot of different kind of animals because they have personalities, as every animal does. And so, yeah, it changed depending on the personality. And in guppies, the bonds doesn't seem to be in how long the animal spent next to another one, which is usually what we use to know there is a bond. But it's more about the frequency. They are often found one close to the other, but not for long length of time. If you're talking about cows, for example, cows, when they have a friend, they stay with a friend all the time for years. So, yeah, we had that on guppies, and we have other fish that have stronger bonds. One very interesting one is, it was a study about pro-social behavior. So the idea was to take fish who are bonding for life, male and female. A bit the same kind of animal than the one I talk about, the judgment bias study. And they took the male out and they split, so the male and the female. Okay, I'm explaining this, so try to visualize this in your head. You have a tank split in 2 parts. The parts closer to us, there will be the male. In the other one, there will be different people. In the part of the male, you have 2 compartments. One compartment with a red cylinder. The other compartment has a blue triangle. Okay, so if the fish gets in the compartment with a red circle, he will receive food, and food will be delivered in the other tank as well. If the fish takes the triangle, the blue triangle, this fish will receive food, but nothing will be delivered in the other tank. So we have a pro-social choice and an anti-social choice. So when there is no one in the other part of the tank, the male is choosing randomly. If there is a male, a possible rival, antisocial, almost 100% of the time antisocial. Now, if there is his wife, yes, this is anthropomorphizing, I don't care, there is his female. This is pro-social choice all the time. And now question, what happens if you put a new female? Is it just because this is a female? Or is it just for their female?
Right.
Well, if their female is just next when they're bringing a new female, antisocial choice all the time. Now, if there is not the female of the male, it will depend on how long he's been separated from his female. At first, it will be antisocial, and after a while, he will start to switch to pro-social choices.
Oh my goodness. Okay, so if his female is next to the other female or next to him, but basically just like in the vicinity, he'll be antisocial around the other female.
Yes.
But if she's gone and she's gone for a while, he'll start to become pro-social with this other female. Oh, that's complex.
Sebastian's take on fish consciousness.
From your perspective, you know so much of what there is to know about fish that we have studied so far. So you've got all of this kind of wealth of knowledge. What is it that feels most compelling to you, that makes you feel like you've got, really, really high confidence that fish are experiencing things?
That most of the papers we have are going in this way, and very few, very, very few are going the other way. So what makes me so certain, and I'm not talking about, I'm really talking about my personal opinion. Yeah,
of course.
I tend to think that emotion. What are emotions? What are emotions used for? They are putting a gloss on what is around us. This stuff has a positive gloss. I need more of this. This one has a negative gloss. And we know that emotions are very, very closely linked to learning. So emotions are something that attract or repel. And it seems pretty obvious that it must have appeared very, very, very early in evolution, because this is how we work. And this is maybe one of the biggest difference with algorithm. Algorithm are following closed loops, and this comes up when animals are more driven by emotions, by value of things, which is made by a kind of limbic system that says, okay, this is good, this is bad, you want more of this, you want less of that. And I don't understand why other animals wouldn't have that. And another thing is, I'm reading a lot about bees, so I know very well the corpus of knowledge on bees at the moment, and we're starting to have the same results in bees. So I'm not 100% certain now bees could be sentient, but the biggest leader of bees research today, Lars Chitka, has said on Twitter that bees are sentient for him. And the results we have are going in this way. So they have a 1 million neurons brain, and the brain of fish are much, much, much bigger. And it's not even, when we split from insects, brains were not existing either. So it's just a convergent evolution.
Yeah.
So yeah, fish have complicated lives. They have social lives, very social lives. I guess we'll talk a bit more about this later, but I already introduced this with cleaner wrasses. Their lives are very complicated. They have challenges that they have to overcome that are as complex as what we find in mammals and birds, maybe more sometimes. So them having no sentience, when we recognize sentience in birds and mammals, it's either you refuse it for everyone, either you accept it for everyone at the moment. Not for everyone, because animals with a brain or central nervous system today, we think at least there should be a kind of global network. Everything should be put in common to make a unified vision of you and this kind of thing. But consciousness probably have many degrees. Sentience have pretty much many degrees, but not degrees on a ladder, degrees more on a circle. You know? But that would sound just weird, actually, that they wouldn't be sentient.
Yeah, just be really surprising to you.